So, hi everyone. This is Heidi because I'm from Zurich, or I'm from Sweden, but I'm working in Zurich. We play that every Friday before TGIF. So that's the cue for when to go and drink beer and have fun with your colleagues. That's the theme song. All right. So I'm Johan. I do incident response and I do forensics at Google. We're going to explore how great tools and collaboration and procedures going to help you scale forensics, right? So I'm not going to talk about wizards today, unfortunately, because it isn't magic. It is about good engineering, and it's about working together and having tools that back you up in that. All right. So I remember my first case, and this was many years ago, long before I started Google. I was working at the university at the time, so my background is system administration and network administration. I had spent years kind of figuring out how systems work and how to make users happy, and digging down into how DNS works, routing, and peering agreements, and the politics and governance behind the internet and so on. So I remember my first case. So my boss called me up, and one of those, Johan, you know about computers. Can you try to figure this out? It looks like one of our servers is hacked. And I was, of course, kind of curious. I haven't done that before, so yeah, challenge accepted, right? But I had no idea what I was doing. Started as a small fire. As many of you already probably know, right? Starts as a small fire. We had one server, and I kind of had no idea what to do, right? I was a total newbie when it comes to this, but I know a thing and two about systems, right, and how systems work. So I kind of stepped back and thought, where's my comfort zone, right? How can I approach this problem? And my comfort zone was system administration, right? And knowing how systems work. So I did that, right? And I did all of the rookie mistakes that you can do when you do your first case, right? I was on my own. I logged into the server, and this is live forensics at its best. I would not do that today, right? Logging into the server while we probably had a active attacker on the server, but I figured out kind of what happened there. And it worked, and I got kind of excited about it because I could use my normal tools. I could use the tools that I was used to use, right? So I had my Unix toolbox with all of the things, right? Sed, grep, awk, and strings, and we all know that strings is probably one of the best forensic tools out there, right? So I could use this, and I got me excited. And I remember this when I was thinking back into this for this case. I still get that kind of excitement, that feeling, because I was in control. And the tools helped me being in control. And that was a great feeling. Because that is what it is about, being a system administrator, right? You just make it work, right? So I grabbed my duct tape and started gluing things together, right? Because this one small fire, of course, became many more fires, right? Because the attacker moved throughout the network and so on. So my approach with logging into the server and doing this live didn't really cut it, right? So I had to try to scale this. So what I did was, go out on the internet, figuring out what to do, and I kind of, started imaging the boxes instead, talking to people, have them image and send them to me. Put this in a central location so I could script my way around, right? I could put all the manual steps in a script and do that for me. So basically just make it work. All right, so let's fast forward many years, and I started working for Google. And I didn't know what to expect when I started there. Kind of how do they approach forensics at Google, right? I didn't really know. But I was happily surprised because they did the exact same thing that I've been doing for many years, right? They were using open source tools, they were using existing tools out there, And they glued it together to a toolbox that was really awesome, right? So I felt just like home. It was basically what I've done for many years, right? So that was great. Google has challenges, and we share these challenges with many others in our industry. First off is the technical scale, of course, right? It's just not one computer anymore, or a couple of them, right? It's more than one computer. But, and that is a challenge in itself. But we're also a company who has valuable information, right? And when you have valuable information, you have attackers that know a thing or two about computers. And when you have an attacker that knows something about computers, they will move fast, right? They will move fast in your network, and you have to be able to keep up, right? As a response team, you have to be able to keep up or be faster than your attackers. We also have another challenge at Google, and that is that we are a very distributed team, right? We're working across time zones, and this is a challenge in itself, because to be able to scale our forensics, and I thought about this when I started Google, right? We had awesome tools, and we were using, I will talk about some of them a bit later. But I was thinking about this, how can we scale this? How can we be able to move as fast as the attackers does, right? And I came to the conclusion that we need to do this with collaboration and communication, because every second matters, right? It's not days anymore counting in response. You have to do this in hours and most of the time in minutes or seconds, right? And every second counts, and every context switch hurts, because whenever you have to hand over information to your colleagues, right? We are a distributed team, and we are a pretty big team. But as soon as you try to hand over, you have your state of mind, and you know this doing forensics, right? You have state in your mind when you're doing forensics, try to figuring out and problem solving, right? And dumping that information down so anyone else can take it over and run with it, that takes time, and you will lose bits and pieces if you don't have great tools that help you, right? So I was thinking about this and kind of came to the conclusion that collaboration, and we need to have collaboration as part of the design for all of the tools that we are building, right? And all of the tools that we are using. All right, so before we talk about tools, I'm passionate about tools because I build tools, and I like to take other people's open source tools and use them and so on. I will talk about that. But before we go into tools, I want to talk about incident management. So this is the coordination part, which is also a very important ingredient when you try to scale your forensic operations, because coordination is key, right? And this was another thing that I was happily surprised when I started Google, because we have a long history and a very strong culture around system administration. So we have a team called SRE, which stands for Site Reliability Engineering. And these are the people that keeps our services up and running, right? So make sure that Gmail never goes down. Make sure that Google search never goes down, right? But when things happen, and bad things happen, right? If something goes wrong, they're there and they are ready to respond to that. And what they did was taking inspiration from the physical world. Looking at the policemen and firefighters and rescue workers responding to physical incidents and catastrophes and so on. Looking at the procedures that they use there, right? And they use a system that is called, we call it IMAG, which is Incident Management at Google. And it's all about communication and having a really strong set kind of chain of command and procedures around that. Because if police and fire workers just going to run around and do their own thing, things will go badly, right? So what this is, and I'm not going to talk in detail about this, and this is a simplified chart, but what it is about setting up a virtual team, right? You set up a virtual team for incident response with a set of chain of command where you have in the top there, you have the incident commander, and this is the person that is important, the role of commanding the whole incident. That person needs to have an overview, and holistic view of the whole response, right? Coordinating different teams. And at Google, right, if you have a service going down, that would be the incident commander talking and coordinating all the different engineering teams, for example, to solve this problem. And we figured from the security team that we can translate this into a security response, right? We can set up the same thing. So if we have a complicated incident that needs a lot of coordination, we use the same technique. So under the incident commander, you set up different roles, right? And there are many others that you can use, right? And if you're thinking about setting up something similar in your organization, you can tweak this, right? But what we almost always need is an operations lead. Because operations is what we do. We're a tech-heavy company, right? So it will almost always be an operations lead. And this is also where you come in, right? And we as forensic analysts come in. This is what we do, right? We're going to be under the operations lead. And our role is going to be to answer the questions that the incident commander has for us. Because he needs those answers as quick as possible in order to make strategic decisions about response, how to take the response to the next step, and to resolve it, right? So we as forensic analysts are going to report back up to our operations lead, and then going to report back to the incident commander, who then coordinates this. And to be able to do that, again, we need really good tooling. We need tooling that works for us, right, and not against us, to have those answers as quick as possible. There are other roles in this also. You have communications lead if you need to communicate with internal or external users. You might need a planning lead if it's a really long-running incident. You might need that for strategic decisions and so on. And you can scale this up and down however you want. So one thing that I tell people if they want to implement something like this, because this, and you should go and read up on the details of it, it's a very efficient system for getting things done, is never mix the roles. This is the pro tip, right? So even if you're an excellent, you think you're an excellent incident commander and an operations lead, you can do both. And I know most of us can, do both roles, but never do them at the same time, right? Because you will not be excellent at doing them at the same time. You have to be excellent at doing one of them, right? So if you are an operations lead, you should do that. If you're a forensic analyst, you should do that, and you should scope down, and your work should be that, because that's how the whole response is going to be excellent. All right. That's about coordination, and it is a very important part. But I also want to talk about tools, because as I said, I'm very passionate about tools, and because tools is the thing that helps us, right? That backs it up and helps us doing a great response in the IMAG procedures. So when I talk about and I think about tools, I usually say that my toolbox is not your toolbox, and my workflow is not your workflow, and that is totally fine, right? Because we all solve our problems in different ways with different tools, but hopefully we can get the same answers, right? And that is totally fine, and I think that is a great feature. And it's also about having flexible tools, and the tools should work with you, right? You need to be able in anger to change your tools and modify your tools, or combine them in new ways that makes, it's possible to answer the questions that you have for that specific problem. So if I had this back in the days when I did my first case, I would be super happy, right? But the ecosystem we have today with open source tools is just amazing, right? And I couldn't fit all of the logos up there. There's so many good logos of the different projects. But I have a bunch of them. So we have tools, open source tools for GRR as a live forensic framework. We have Libby, which is all about parsing, and Plaso for timelining, Timesketch for analysis. But we also have MISP, which is, I bet most of you know what it is, right? It is a threat sharing platform. It's an open platform for sharing threat intelligence. That is not forensics per se, but it backs up, it helps us, right? It helps us in our investigations to get that information and integrate that into our tools. We also have OS Query from Facebook, which is a great tool for finding badness on your network or fetching files. And fetching files is great when we want to do forensics on artifacts. And you know, all of us know about SleuthKit and Autopsy for disk forensics, amazing projects, right? We have volatility for memory analysis, which becomes, you know, more important every day. These are great tools, but it's not only about the big projects and you know, the big frameworks out there. It's also about all the small tools that we build here. And I know a lot of you building tools, putting it out there and open sourcing all the small scripts that we have, right? Maybe we're just gluing some tools together, but that's great because it's creativity and it helps us, right? All right, so you hear me talk about open source a lot, and why do I care so much about open source, and why do I think it's important? Well, first off, I think open source it's about building together, right? And it's about having fun and being creative with the tools that we have, right? And I mentioned this, that, you know, a fantastic feeling is when someone else uses your tool, even if it's just a small script, right? But they use your tool in a slightly different way, or they're solving a different problem with your tool. That's a great feeling, because you step out of your bubble, right? And you step out of your tunnel vision with your tools, that this is the result that I get and I'm comfortable with that, right? But then you see someone else using your tool in a completely different way and just opens up, right? And you can start, you know, getting more creativity and understanding different use cases and so on. I think that's a great aspect of open source, and it's not only about the source, it's also about openness, right? And sharing. It also has other benefits. And that is about being able to verify your results. And I know that there are other ways of doing this. It's not just about having the code available, right? But if I have a parser and I have a new file format and I have a parser for it, I want to understand how, you know, I want to be able to reason about how this parser is looking at this file format and giving me the results that it does. I would like to be able to understand why. Because if I can do that, and if I can be certain that this is actually correct, right, I can reason about this, then I can apply that to other, if I have a less transparent system or a black box where, you know, I have input and then I have output, I can verify the results and being confident, because maybe this black box is a fantastic product and I want to use it. But then I can verify that and I can be confident that it gives me the results that it's supposed to do, right? It's not only about the source code being open. It's also about open systems and integrations, right? Because if I'm going to be hit tomorrow with, you know, you have to process 100 images tomorrow. And if I'm stuck with 3 computers in a corner with 3 dongles in them, that restricts me to process on those 3 computers, it's just going to take so long, right? I need software that is flexible and open enough and allows me to not have those restrictions, right? If I want to spin up 500 CPUs in a cloud somewhere to do the processing, I want to be able to do that, and open systems give you that, and open source gives you that. And don't take me wrong, there are amazing commercial softwares out there, right, that do amazing things. And when I look at them, I look at how can I integrate this into my workflow. That's also important for us to think about, right? When we buy new software, or when we are looking at new software and it's not open, right? It has its restrictions. But if you have great integration points, APIs, well-defined APIs, you can start plugging this system in, this amazing system, into your workflow, and you can use it. That's important. So this is open source for me. And also I'm a bit biased because, as I mentioned, I'm coming from the university world, and that's the de facto standard of how you develop software is open source, and you're just happy if someone else uses your software. So I'm a bit biased, but I believe in open source, and I think that we have a great community where we are building a lot of great open source tools. All right, so I'm going to talk about some specific tools because I like it. We're going to talk about GRR, and I say here that, you know, what we're trying to solve here, I just need a file, and that is actually not fair to GRR, because GRR is so much more. So GRR, for those who don't know, is a live forensic framework and a system, right? It gives you the ability to have, so remember back in my first case when I logged onto the server and I did super live response, right? Side by side with the attacker. I could do this with GRR today, but without doing that, doing it the right way, right? Because it's an agent-based, so you have an endpoint and you have a server, and the server can send asynchronous messages to the endpoints and asking for actions. We call them flows. So a flow could be, for example, list this directory for me, or fetch this file, or fetch this specific artifact. And all of that will be rendered on the server side with a collaborative interface where many analysts can go in and they can analyze the system as if they were on the system, but they never touch the end system. It's also very great for us in forensics and to be able to hook this up into our workflows because it's a great collection engine. So GRR is more than a collection engine, but let's call it that for now. It has a feature called artifacts and artifact support. So what that means is we have an open repository up on GitHub with artifact definitions. And these are basically just pointers to where to find specific files on specific platforms. But the end user experience for us is great, right? Because as an analyst, I don't have to care about where to find the files. I just tell the system that, please give me, for example, all the browser history files from this host. And it will figure out the platform, it will figure out where to find the files for all of the users on the system, and it will figure out where the different browser history files are for Firefox, Chrome, Internet Explorer, and all of them, right? So as an end user, it's great. I just tell it to give me that data so I can analyze that, and you figure out where it is. GRR is also very extensible and scriptable and customizable, right? And it has a great API again. It is open source, but it also has a great API so you can hook this up into your workflows. All right, so now we have, say that we have collected these artifacts, say that we have maybe collected, some registry highs, event logs, browser history files, maybe the MFT, right? Now we need to do something with that. Now we need to process this so we can actually extract something. And I'm a big, as in the introduction they said this, I'm a big timeline fan, right? I like timelines. This is how I work. This is how my brain works, right? I want to see what happened on the systems or many systems, at a point in time and understand and step back, right? And figuring out for example, what an attacker did on a system. And to be able to do this, we need to parse a lot of files. We need to parse data, right? So Plaso is a framework for exactly that. It comes from a very old project called Log2Timeline. This was a Perl script back in the days. And I actually learned just today that it was actually from SANS that this came from the idea came from in the beginning. It was my colleague, Christian Gudjonsson, who wrote the first Perl script for that. Then we hired him and told him to rewrite it in Python. But that's when Plaso became a thing. And it's amazing because you just pointed to data. That could be a full disk image, for example. It will figure out everything for you, what OS it is, what parsers to run, and so on and so forth. But you can also point it to a set of files. Just parse those files and create timestamp events out of that. So Plaso is built up around a bunch of parsers for understanding different file formats and log files and so on, and output modules for outputting this resulting pile of events that we get into a usable format for us. Default one is a CSV file, but there are others. There are others for different databases and so on, and I will talk about that a bit when we come to Timesketch. All right, so we cannot really talk about Plaso without talking about Libby, and this is known by some, but not by many. It's an amazing collection of libraries. So this is my colleague Joachim Metz, who has written more than 60 libraries for parsing different file formats, for understanding how VSS works, and you can integrate that into your other programs. It's an amazing collection. It's basically all the libraries that you will ever need, right? So if you want to parse an event log, if you want to parse a registry file, if you want to parse different file formats out there, you can turn to Libby, right? And this is actually one of my tips for people coming into digital forensics and especially open source digital forensics, is to take a look at Libby, right? All of them, all of these libraries have tools together with them, right? So when you compile it, you'll get a tool, and you can use that in your bash script to automate things for unencrypting a encrypted disk image if they had a rescue key, for example, list and access all of the volume shadow copies. All of this is possible with Libby. And this is also what underpins most of the parsers in Plaso. So that's why I want to bring it up. This is an amazing collection, and I recommend you to take a look at it. All right, so as amazing as Plaso is, right, it gives you a lot of data. For a normal Windows system, we extract around 4 to 5 million events, depending, or more than that. And the default output format is CSV files. And that was the format, and that was the way we did analysis when I started Google, right? It was still there, right? We had CSV files that we put out, and we set grep and awk through them, we slice and dice them, and filtering out different things, put that into smaller files and so on. And maybe this is kind of okay if you have a one-off, or if you're the only analyst, right? It's still messy, but it kind of works, and it is powerful, don't get me wrong. But going back to how do we scale forensics? Well, we scale forensics with collaboration, right? And collaborating on this is very difficult because you have to share the files, right? You have to link them, you have to understand what the files are, and so on and so forth. Maybe you have to send the grep commands that you're using to your colleagues and so on. It doesn't really scale. And this is where I actually started thinking about Timesketch or a system around this. How can we build a collaborative system around timeline analysis? So the first, and this was very early on when I started at Google, the first thing that I thought of was, of course, you just put this in a database and be done with it, right? And that is fine. The problem is that Plaso extracts a lot of rich information for you, right? And all of the different parsers extract different data. Internally, that is represented as a JSON document and JSON object, and that is very hard to model as a SQL schema if you want to use a system like that. And back at the time when I started thinking about it, it was very popular with NoSQL databases, like document stored databases. So I tried to put the information from Plaso into MongoDB and RIAC and other databases, open source databases. They're all amazing projects, but it didn't really solve my problem because I wanted to search my data. I wanted to be able to explore it, right? This is how I work. And I wanted it to be a collaborative system. So then I turned to Lucene, which is a library for full text indexing. And a system on top of that called Elasticsearch. And I was a bit skeptical at the time, right? So how well would it scale? Would it scale to all of the timelines that I needed to scale? Would I build one big index that would explode over time, right? And how long would it take to ingest all of these events? But I hacked away and I tried it out. So I built a output module for Plaso for outputting the internal state, so the JSON representation of this directly into Elasticsearch, and I start playing with it, right? Just get a feel of it. And I used the built-in exploration tool. It's called Kibana for Elasticsearch, and it was great, right? Because it turned out that I didn't have to have one big index. I could spread the timelines over many smaller indexes, and then I could query and cross them, and it was still really, really fast. It was also pretty fast to ingest an index, because if that would have taken hours and hours and hours, it kind of defeats the purpose, right? But it was fast enough. So I got excited about this, playing around with the Kibana, but it had its limitation. It's an amazing tool for data exploration. But I wanted something that could help us, right? A collaborative tool for timeline analysis. And that's where Timesketch came. So I started building my own front end to Elasticsearch to do this. And it became this, right? It's a rich interface. And this was kind of, when you are I remember this, the first big run I did was I ingested like 40 million or 50 million events right into Elasticsearch. And I started querying it, and it was so fast. I could get results and filter results within milliseconds, right? And I started thinking about this, how can I use this? What does this give me, right? Well, it gave me the possibility to build really rich user interfaces on top of this that are specialized for us, for our use cases in digital forensics, right? It is not a general purpose tool, it's a tool for us. It's a tool for collaboration. So you see here, you have features that you're if you're using other systems like this, we have saved views that you can share with your colleagues, right? You can annotate the events with labels and stars and comment on them. You can work on the case simultaneously with many users. All of your analysts can be in the same investigation. So basically, instead of handing over all of your state, you put your state into this system that you have in your head, and you offload that, and your fellow colleagues can continue. So if you're in a messy and big investigation, you can just continue working 24/7. And the feature that putting timelines in its own indexes gives you the possibility to just colorize them. It's a super simple feature, but it's extremely powerful to just see how, for example, attackers move across different systems. And doing multi-timeline analysis was a great feeling when we started building this system. And also you see here, I like that, I call them time bubbles. So when you have, if you're sitting in Excel, for example, and you have all of these rows with your timeline, right? It's really hard to spot when you have big gaps in the times, right? But with this really fast system, we're able to build these interfaces where we can have time bubbles saying that, hey, 7 days went through here, right? Because it's so fast. Timesketch has many other features, and I recommend you to go and take a look. I'm here until Saturday also, and I wrote the thing, so catch me afterwards if you want to know more. All right, so automation. Now we have great collection, right, with GRR. We have processing with Plaso, which automates most of the processing for us. And we have analysis in Timesketch, but we also need automation. Automation doesn't solve all of your problems, but it solves repetitive tasks for you. It gives back time to you as an analyst to do what is actually important, right? And that is analysis. I don't want my fellow colleagues and analysts, and they don't have to know about the command line flags to bulk extractor or command line flags to log to timeline. I don't really care, right? You can read a manual page for that. I care for them to have the data available to them to be able to analyze this, right? And automation comes into play there. So we have another open source project called Turbinia, who tries to do this. So it's very, again, geared towards our use cases for forensic processing of evidence and digital artifacts. And we found this, that the more you automate, the more time you get to automate even more, right? And then all of a sudden you end up with a lot of time doing important things. So automation is important, and we should try to automate most of the processing for us. And with the open systems and open source systems that we have, we can build this, and we can build this and scale this however we want. All right, so to wrap this up and talk about what have we covered today. I've talked about open source and flexibility and building systems without restrictions. And I think that is important, right? So imagine that you have to do an investigation on this mainframe. Would your tools be able to do that? Would you be ready for that? Would you be able to change your tools, adapt your tools to this situation, right? And I want to ask you, if your workload is going to increase 10x or 100x, will you be able to handle that? Will your tools be able to back you up and help you with that? Or will they just be in the way? Because if your tool is going to be in the way and you cannot handle that load, you should take a look at the open source ecosystems out there, and we can build this, and we can build this together.